You may have looked at the schedule earlier on and perhaps didn't see my face. You probably saw Christian's face in this session. I do not look like Christian, and I am not Christian. Unfortunately, Christian Zimbabwe was not able to come. But yet he is an avid communicator and advocate for developers and teacher. In fact, Christian does a lot of training with Scotch.io. He's one of the leading Nigerian teachers bringing the African community. And a lot of what he talks about is bringing the community together to better enrich both the developer experience and ultimately the end user experience. So unfortunately, Christian wasn't able to join us because of visa issues, because he's from Nigeria. So you're stuck with me. But I want to emphasize that a lot of this talk is actually Christian's talk. Because he's done a lot of work around service workers, and I'm standing on his shoulders to talk to you about this stuff. So there's three things I want to walk through today. One part is around performance. The reason why we want to talk about service workers. What is it that we're going to get out of it? Why do we care about service workers? The second part is some of the levers that we can use to improve that performance, particularly as it comes to media workflows. And then third, the real payoff is actually using service workers and some code that I'll show you as we go through. Just a show of hands, how many people have used service workers already? How many people have heard of service workers? The majority of people? Awesome. How many people are here just for the coffee? All right, I see that hand. Great. So we often think of the web as this beautiful, uniform experience. I load up a web page, right? I load up a website. It's perfect. But if we look at the user experience, and yesterday I did a workshop on a WebDriver and looking at that, how do we automate the web experience? And part of what I talked about is that there are metrics when you look at loading, because I'm sure we've all experienced it sometimes, that it's not always the same. It's not always instant. And there's in the web performance part of the community, which I've spent a lot of time in, we've come to build these metrics, and we often look at the users in the real world, and we stack them up based on those metrics of, say, web page load time. And so you'll often see a histogram like this. And perhaps you've built these kind of histograms as well. If you looked on the x-axis, this is the number of seconds that a user has taken to load that web page or get to that key performance indicator on your site. On the y-axis is the population of that cohort size. And so you can see here that there's often a long tail. Not everybody gets the same experience. And that same experience, there's some poor guy that took 48 seconds. In fact, there's quite a few people way down that tail. And there's a lot of research out there that says, hey, what's the best time? Does it matter? It started off actually with a bunch of work by Cliff Crocker. There's a famous Walmart study showing that, hey, performance directly correlates with my business metrics. More people visit, more people stay engaged, more people buy products if it's faster. And why is that? Well, lizard brain, right? We get distracted, we get, things don't load, and oh, the bus came, I put my phone away, I didn't actually check out. And if you're interested in this, there's a ton of research out there, WPOstats.com, constantly publishing material about how it's impacted the business, how focusing on performance, improving your apps can make a difference. And the general consensus is that there's this magic number, around 2 seconds. Now, why do we think about the 2-second mark? And you'll notice I put you and not you, because all of us here, I'm going to venture a guess, we're all technologists. We probably have a Pixel 2, an S9, an iPhone X in our pockets. We have the best phones and the latest operating systems because that's part of who we are, right? That as technologists. But we are not the average user. the majority of people buy a phone, like my father-in-law, who came back from the store and said, hey, I got a new Android phone. I'm like, cool. I looked at it, brand new, Android 4. I'm like, what's going on here? Like, this is a new phone. It cost me $0. Yeah, okay. The ecosystem is never as we expect it. And so there's OpenSignal. They've done a lot of telemetry research on what's out there. You may have seen some of these diagrams before. They've been tracking the browser ecosystem and the device ecosystem. 2012, there's some 4,000 different active Android devices. And 3 years later, we're sitting at, well, this is 2015 still, 24,000 Android devices. This is now stable, probably closer to 30,000. But this is different devices with different viewports and, unfortunately, different CPU and RAM. In fact, Jen Fitzpatrick famously quoted at Google I/O that 25% of brand new Android phones, this is as of last year, 25% of brand new Android phones only have half a gig of RAM. Now, that's not my phone, but if 25% of brand new Android phones are like this, what's that long tail look like? And so these have impacts as we load the user. So this is a talk really about the little guy. We want to talk about him as the, how can we improve that user experience out there? Now, there are a lot of different aspects when we talk about the web, and we usually think about the users that are out there. Now, Christian will often talk about the next billion users. Who are these people? Even the baby up there, he's part of that next billion users that are yet to come online. And these are not just about those that are have the lower end phones, but we're also talking about those in rural areas, in limited network connectivity. I've got a good friend who works in healthcare. So I'm from Canada, and so she ventures up north. And so relative, you think of Canada being north, there's even more north. And she's a doctor that spends time in these communities, and she spends most of it offline because all they've got is a limited cellular connectivity, and yet she's got to do radiology, X-ray evaluations. She's got to do communication with different hospitals. The experience is not always uniform, even here in the US, even here in North America. And these next billion users are not that far away. We also have accessibility. We also have a lot of different limitations that these next billion users are coming online, but we've got to bring a lot of capabilities to support that. So when we often look at the web, we probably think of a web page loading with all of these things. Now, how many people get those help desk tickets about the page is taking too long to load, your app is too slow? Got a few hands. All right. So what can we do about this? And so this is where we're going to start talking about service workers. Now, as many of you have heard of service workers, it's this brand new, shiny tool that can do all things. It's singing, dancing, it'll save the world. Now, the service worker spec has been around for a couple of years, and it's evolved, and we've learned, and we've adjusted. And Google's been a very strong proponent of it, and we found access to it within the Chrome ecosystem. It's fairly stable. So what can we do with service workers? Well, it starts off by the number one thing you'll hear about is caching and be able to provide that offline experience. As well, because we're part of that life cycle, we're able to get involved in the middle and intercept those requests as they come through from the browser. And we make these requests back and forth. We can adjust the resources, or perhaps, and this is where the offline mode really comes off in, is to be able to say, oh, you're not really on the internet, I'm going to give you an old version, even though it's not supposed to be used. You're offline, we're going to give you that. But there's also a lot of capabilities that move into the progressive web apps. You may have heard of PWAs, where you now can blend your natural app experience with a manifest file and bring a home screen icon and an app experience, even though it's actually a web page. So installing that web page on your desktop without having to build a full stack app. And the promise, of course, in Service Workers, when you combine it with manifests and progressive web apps, is that you can both enhance your experience at the core level, but you can also unify your dev team. You don't have to worry about it, Android and iOS and a web team. You can now unify it under one umbrella. So why do we care? Actually, I'll come back to this in a second. So we typically think about loading our JavaScript. Hey, it's cool, we just load it. And unfortunately, when we do a page refresh, that JavaScript has to be reloaded, right? Because the page, well, it's not known until we get the HTML. Then we load the JavaScript, and even if it's from cache, you still have to reevaluate and before it's actually executed inline on the page, before you can start manipulating the DOM on the browser and so forth. So what we want to be able to do is get in line and be able to preserve some JavaScript that's running across page transitions so that you don't have to worry about it being reloaded. You actually still have that JavaScript working. And this gives us a benefit of being able to get in early on the next page. Now, there's a little bit of a racy part of this. Service workers are loaded later. So the first hit is when you register the service worker. So the first time the visitor comes to your site, you're just going to be able to load the service worker. But once they're there, then the next page, your loyal users, as they transition through or they come back tomorrow, you'll have this little bit of JavaScript that you can that's running, it's hooked onto events that you can intercept and move on to the next activity. Turning on service workers, it's actually really, really simple. Just check for the service worker navigation. Off of the navigator, look for service worker, and just register your little bit of JavaScript. Pretty straightforward. And once you're there, if you're looking at your dev tools, you'll probably see it right at the end here. You'll see the service worker loaded. Now, it's loaded as a low priority because, of course, the browser has other things to do. The first time you've hit the web page, first time you're going to the BBC, you want to load the page. You want to get the news to the person. Once you've done that, then the JavaScript that's executed to load the service worker carries on. But once it's there, you are in control. That service worker is running as a person clicks on the next news article, as a person moves across or comes back tomorrow. So you may have seen diagrams like this. What is it the service worker really is letting us do? And I lost, oh, there you go. Service worker is letting us act in the middle of the page as it makes these requests. Some people liken it to a proxy. It's not quite a proxy, but it's a good analogy. It allows us to take the request and look at, manipulate that fetch request on the wire and redirect it to either an existing cache entry or adjust the request as it goes all the way through. And then the obvious use cases are where you have like big platforms. You've got content that's being jammed in by your content creation team that went and watched a YouTube video. And they say, oh, I can just punch this little bit of HTML snippet, and away we go. And this service worker now lets you act as a safety net, as one function, to ensure that, hey, those images for that banner is going to be, we're going to change that, make sure it's actually a JPEG, make sure we make the JPEG request, or make sure that the image is, that the content is online. What other things can we do with these kind of requests? And so, I'm from Cloudinary. I focus on images, and I didn't mention it before, but I'm one of the authors of High Performance Images. I spend a lot of time. Everything looks like images and video problems to me. So bear with me here. But image optimization, video optimization is actually one of the best things you can use Service Worker, aside from the offline experience. Because it allows you to not only do progressive loading, not only do adjusting resizes, but you can also do prefetching. Go start warming up the cache ahead of time instead of responding to the user. There's a number of these functions and features that you can enhance your site experience using Service Workers. So now that we've loaded our Service Worker, what can we do inside it? Now, a Service Worker is really just your plain old JavaScript. So you can overload a lot of the same library code that you've been using in other spots. A really simple example here, and this is just the JavaScript, you add an event listener for fetch. Now fetch, if you're not familiar, is the preferred model instead of using XHR or XML HTTP API calls. Use fetch, and so we're just going to add an event listener for fetch. And so whenever a network request for fetch happens, we're going to be called before it egresses onto the network, before it makes the call to the network. And then we can just take a look at, say, is this fetch from an image? Is this from JavaScript? Is this from, what DOM element is this initiating from? So we can quickly look at that by looking at the request object on the fetch. And in this case here, I'm looking for an image. And then we can just pass on and say, this event, I'm going to respond with a new fetch. Now, because I'm responding from this event with a fetch, I'm not going to be called. It's not going to loop back. It's going to be passed on to the next layer. But this respond with allows me to respond with either my straight base64 byte stream or with, in this case, I'm just passing in a new URL for it to go. Well, that's not a new URL. It's the same thing. So this is not really doing anything. Let's add a little function called downscaled. That function will now change the URL a little bit and send that up. Now, why would we want to change our URLs? Well, as I said, resizing, and okay, those are nice things to say. Let's talk about these user experiences, because one of the things I mentioned is that not only our devices are they lots of different viewport sizes and CPU and RAM, but also our networks are not as stable as we would like to think of. This is, again, research from OpenSignal published in December last year from a global sample. You can take a look at their research. And each one of these dots is the median experience per country. And on the x-axis, you have the speed. So on cellular, hey, it looks like the world's actually getting pretty fast. Our maximum speeds look like they're in the 30, 40, 35 megabits per second. If we can ramp up and get that throughput, great. But look at that availability axis. This is when the device wants network activity, is it there? You'd expect, perhaps, that the US and Canada would be that dot in the upper right-hand corner. It's not. Canada and the US sit right in the middle at about the 75% availability, meaning that 25% of the time, even here in the US, 25% of the time, users pull up their phone and they can't do anything. They can't go to the next page when they want to. Or it's slower than they expect. It advertises 4 bars, but everything's slow as all get out. And so it's because of this that we might want to actually consider changing how the user what kind of resources we send to them. And one of the best ways for us to do that is if we can send, when they make an image request or video, send them less bytes than before. Now, of course, the simple answer is always, okay, if you've heard of responsive web, responsive images, but that just means that if you've got a phone, you're going to get a very big pixel-wide image. What else can we do with it? Well, so I did a bunch of research in preparing for the book, looking at the top 1 million images. And this is a CDF, cumulative distribution function, of looking at image width and the bytes. And so the legend here is different congestion window segments. But basically, if you look at that 0.5 and kind of walk across, you can see that as we increase the width, basically we're doubling each one of those lines is basically a double of our byte size. And so the gap between a 600 pixel wide image and an 800 pixel wide image is nearly twice the bytes. So let me just put this in a different view. This is the median experience. So that 600 pixel wide image, the median is about 30K. Going up to 800K is 74K. That's the median. The 95th percentile is even wider distribution. So the best way for you to actually reduce bytes is not by changing the quality rate, quality index on, no, don't go to quality 50. Don't change your video bits per second. Actually change the dimensions of your image or your video. Change it from a 1080p to 720 to a 360. Change the dimensions of your images. Instead of sending them a nice, crisp 1,000 pixel image, send them a 600 pixel image. And let the browser do GPU upscaling. So if we can detect when the browser is in these hostile network environments, when the browser is in an environment that's not the greatest, then maybe we can just change the dimensions of this image. And it will come across faster, and we'll get the best of all of the worlds. And so to do that, one other thing I'll highlight here is it actually benefits not just for the network, it actually benefits for the device itself. If the device is low in memory or doesn't have a lot of memory, changing the dimensions also impacts the amount of memory that the browser has to decode. Because remember that this image that comes across or video that comes across, that's the compressed form. It's got to be inflated before it passes it over to the GPU, which means that if you have, say, an image of the Toronto skyline here, 1,200 pixels, that each one of those pixels has to be inflated by 4 bytes for red, green, blue, and alpha. That's if you've got standard sRGB. It's actually 10 bits per channel with P3. So it's a lot of RAM. So instead of that 20K image that you might be sending across, it's now 2.5 megabytes of RAM, which you might think, it's not a big deal. But for video, that's a lot of RAM you've got to decode and manage around. For a lot of image heavy, you've got rich content as people scrolling through your Instagram feed. All of those images have to be decoded and managed in memory. So the same function that you can do to save bytes across the wire, by reducing the dimensions, can dramatically save the actual memory use. So that inside of that service worker, we've got some great APIs we can use. We can take a look at that fetch event and just check to see, hey, is the device already in save data mode? In Chrome, the user can opt in to the client hint called save data. Or we can take a look at the navigator connection. Navigator connection reports back the effective type. And there's actually some great enhancements coming, or have actually landed inside of Chrome to bring this. But this allows you to see, hey, is this device in the effective 2G or 3G environment? Or we can even take a look at the device memory. Because we're inside the context of the main application, we can see the device memory and say, hey, do they have less than a gig of RAM? Then maybe we'll take action here. All right, enough blathering. Let's take this for a spin. So what I want to do, and this is where we see how well end show. Cool. Going to make sure these are mirrored. Okay, so here I've got a little code pen, and I'm just going to reload this page, and you will see this service worker. Actually, let me load it up in a new incognito. On the network tab here, you'll see at the very end, do you see this service worker loaded? It was loaded at the very end after all of the things were done to load this page. Now, this first request, when we made the request, let's filter for our images. Ooh, okay. you'll notice that this image was 248 kilobytes. Now, I'm going to change my environment here. I'm just going to emulate a 2G environment. This is part of Chrome Developer Tools. They've got a lot of capabilities for you to empathize with those users that may not have the best experience, changing CPU, changing memory, changing network, changing display. And so now I'm going to refresh this page. And if I am, okay, and you can see it's going to chug along, take a little bit of time to refresh because I'm pretending to be on a 2G environment. Chug, chug, chug. Oh, this would really suck if this was the real world. Oh. All right. Now, where'd my image go? If this worked, demo time, yeah. That 200K image is now a 6 kilobyte image. If I can zoom in here, you can see it. 6 kilobytes instead of that 200K. And that's my service worker taking action and intercepting the request and saying, oh, I see that you're on a 2G connection. Actually, let's go take a look at that code so you know that I'm not lying to you here. All right, so down here you can see that it's that same code, so send the downscaled, and it's checking to see my effective connection type to see if it's 2G. So this is one way that we can reduce the bytes across the wire just by checking to see if the user is in a hostile network environment and adjust the dimensions of the page going through. So what else can we do with this? Now there's a bunch of other capabilities. As I mentioned, one of the common ones is around caching and making sure that things can work offline. But there are other aspects that we can also do. And let me show you a few experimental aspects. One is around progressive images. Has anybody heard of progressive JPEGs? A few hands. You've probably experienced it where you see that image and it kind of fades in and it becomes clear. It goes from blurry to clear. Well, it turns out that you can use that in a couple other ways. When an image like JPEG or JPEG 2000, these are all images that can support this progressive format, which means that they have scan layers. And let me just show you what I mean by a scan layer. If I've got an image here, and at each layer, it adds more and more detail. So the first scan layer in a JPEG is pretty gross. I don't know what that is. 2, 3. Okay, it's starting to get a little clearer. 5. Once we get to this layers out here, this image that we are, and I'm going to get down to a reasonable. You can see that this image starts to come into clarity, but at the very early stages of the scan layers, it's very gross. Now, this is another aspect, another technique that we can use, particularly in responsive images, where we want to send maybe a smaller image to a smaller display and a larger image to a larger display, where perhaps we don't want to adjust it for network, we just want to make sure that we send the right size, and we don't want to necessarily make different versions. We don't want to resize all the different widths all along the way. So this technique here, and this is very experimental that Eric has been working on, allows us to just load maybe just a little bit of the beginning, and if we're shrinking it down, that little bit of the beginning is actually enough to make it a clear image in a smaller context. So here we have, I'm just loading it here. I've got a nice big display. It's loading the whole thing because I've got a big display. But let me just adjust this and turn it into, I'm going to pretend this is let's not use an iPhone. Let's use a Pixel 2. All right, so here we have the image is fairly small. I'm going to reload this image. And because it knows that I'm in a smaller context, I've only loaded 72 kilobytes of the 200 kilobytes, just because it's a smaller display, smaller form factor. So what I'm doing is I'm actually using the service worker under the hood, and it's figuring out, oh, instead of loading the whole image, let's turn this into a range response and load the first 20K, and then maybe we'll just do a few chunks of that range request till we get enough for this loaded display. So this allows us to do some very low-level network interactions that that you normally can't do in JavaScript. And if you can, it's going to be limited to your capabilities. In this example here, we're intercepting all of the image requests or all of the video requests and be able to change the way that it dynamically loads. All right. So there's a lot of capabilities that we can use service workers for. Some of the other ones that, as I mentioned, are for lazy loading and below the fold. At the end of the day, what we want to do is we want to use service workers to help improve the user experience. But it does feel a little weird sometimes because it's not exactly, I'm creating a service that's going to run in the background that's not exactly like real world. Now, what I can share, though, is if you look at those out in the industry that have used and implemented service workers for multiple purposes, whether it's for just simply offline or others, that the results have been great. Flipkart from India has seen huge adoption improvement because, again, India suffers from the same kind of challenges of being a very big country with very tight spots. We've got great cellular connectivity, but a lot of the rural areas don't have the same kind of stable network. And so by changing and using service workers, they've improved not only the conversion rates in the country, but also out of country. Similarly, housing.com, similar kind of improved experience, that bounce rate, because you want to reward your loyal users, and whatever you're doing that slows the site down, they're going to bounce. And so if you can improve that experience, that'd be great. Now, one last objection you're probably going to throw at me and say, well, okay, interesting. There's some cool things we can do for videos and images and other content with service workers if I know that all my users are on Chrome and Android. But what about the other browser that we shall not mention? So the good news is that Safari 11 brought in service workers. And service workers, they've had a little bit of a rough patch as the adoption has come through. But as of now, at 11.4, and as we look to iOS 12, service workers are rock solid. And this just goes to show that the benefit here is not just to the Android ecosystem, but the benefit is ultimately to the end user. And when it's good for the end user for battery, when it's good for the end user for network saving data, then you'll see adoption across the playing field here. So with that, let's recognize that we're not the typical user, that you and I, we have fancy gadgets, and not all the time do we remember that, that things are not as stable as we probably experience things, that our experience is not the common user. So let's use service workers among our normal tool belt of techniques to improve the user experience, but use it to adapt the user experience just in time. And of course, use offline caching in this process. And when the specific action I'm sharing with you today is when we talk about images and video, probably the biggest win you can get is actually reducing the byte size by reducing the dimensions and let the GPU do the upscaling to improve that, not only network, but also memory and battery. So with that, thank you very much, and let's continue to remember the little guy. Thank you.
So we have some time for questions.
Oh dear. I don't see any hands.
Yeah, I see actually a lot over here. Wow.
I just had one question. There, in your code, you had save data as like one of the fetch headers.
Yeah.
When you were loading the images, were they all being loaded via fetch, or were they image tags?
Well, so the image tags, they are image tags, but they initiate fetch requests under the hood, right? So what's happened over the last number of years is all of the API calls, particularly because of Service Worker, are exposed as fetch events. So before the image tag is picked up by the preloader, so that's the the thread that walks ahead, picks up things, and stuffs the network, or through the regular DOM loader. Those events, before they go through and make the IPC call, the inter-process call, so usually your browser tab has to make an IPC call, then to go to the cache, and then it says, oh, I don't have it in cache, I go to the network. So before that now, it actually creates this fetch event. So it is an image tag, but it's also a fetch event for your service worker. So it looks like it was some code that was created. So it's consistent is what it becomes. Make sense?
I have a question about polyfills. What about that feature support with images? Can polyfills handle this?
It's racy. So polyfills so my general guidance is, number one, in general for service workers, think of them as a way to progressively enhance your site. So your site should be fully operational without service workers and without polyfills, without any other enhancements, because the lowest common denominator will likely be, as much as we like to think that everybody has the latest version of Chrome, latest version of iOS and Safari like we do, the reality is a very long tail. There's a lot of folks out there that have 1, 2, 3-year-old browsers. So the polyfill aspect, the first is make sure that your code is consistent even without service workers. Now, enhancing it like I've been doing here, detecting the network and things like that, they're very racy because the browser is fully engineered to try to find things through your page and get them in the network as fast as possible so that you're able to execute them. The raciness comes in, if I have JavaScript that's going to block, I need to be able to block before the preloader finds things, which means the only way to do that is to inject my image tags by JavaScript, which now just kind of creates this whole cascade of events. It becomes messy, and it's going to result in a slower page. So the end result I would recommend is think of service workers to enhance for the next page, and make sure your default at least has a reasonable experience.
If there aren't any other questions, then I just want to thank you, Colin, especially for crossing NAFTA borders in order to replace somebody who couldn't make it into the country. So thank
I had to
you
give
very
all
much.
my aluminum
As
back
a
before.
fellow Canadian, I thank you.
Awesome. Thank you.